Hello, and welcome to our video with the latest advancements in Meta for version 22. Meta covers a wide range of disciplines, which we will go through in this video. Let's start with the solutions for GUI and graphics, and more specifically, with improvements in graphics performance. From version 22.1, our new graphics kernel supports line elements as well, besides shell and solid elements which were supported in previous versions. We benchmarked a model comprising 10 million shell elements, 3.5 million solid elements, 640,000 line elements, and 15,000 parts. Regarding model handling, version 22.1 is up to 6.8 times faster than the previous version when the model is shaded, and up to 6.5 times faster when fringe is enabled. Regarding animation, version 22.1 is up to 2.8 times faster when the model is shaded, and up to 2.2 times faster when fringe is enabled. It is important to note that the GPU memory usage in Meta is very low compared to other competitive software. Furthermore, there are additional graphics performance improvements for models containing shell and solid elements only. Namely, in a model with 10 million shell and 3.5 million solid elements, and regarding model handling, version 22.1 is 1.38 times faster when the model is shaded, and up to 1.43 times faster when fringe is enabled. With regards to model animation, version 22.1 is up to 1.26 times faster when the model is shaded, and up to 1.22 times faster when fringe is enabled. Further reduction in GPU memory usage has also been achieved. Moving on to settings, it is now possible to see from where a palette or a color is loaded, whether that is an XML or a defaults file. We have added buttons in Animation Toolbar to go to the next and previous state and to start and pause the animation. It is also possible to resize Meta Info window exactly like in Anza using the Shift and middle mouse buttons. Another new feature is the new Detail on Demand setting, which has been introduced and enables adjusting the model mesh details. The next new feature refers to the button manager. Session shortcuts containing session files or session commands can now be created. These shortcuts can be added as buttons to custom toolbars and can be docked in the main Meta window. The session commands can then be executed by pressing the respective buttons. The window export to file after selecting File Save As has been reorganized. The options of secondary importance have been placed in an advanced options group which is hidden by default. Moving on to the camera advancements, the camera tool is now common between Anza and Meta. There is an improved GUI for easier handling of the advanced settings. Zooming in or out from within the camera tool on the 2D viewports is now realized by the mouse wheel instead of a slider. In previous versions, it was possible to rotate the model with respect to the screen axis using Ctrl and F1 until F6 buttons. The global axis rotation option is now supported in the Views toolbar, which allows to toggle to model rotation relative to the global axis instead of the screen axis. Another new feature is the redesign of the settings card regarding drawing of model and geometry. Also, ZBrush and SPR elements can now be drawn as spheres for better visualization. Now let's move on to the solutions for model and results handling. Regarding LSDyna results, major improvement can be noticed in the rendering time for both scalar and vector results that are calculated from tensor component values. Another new feature is a new setting that applies to Abaqus and Astran DEX to convert second-order shell and solid elements to first-order when reading a model's geometry. Results are maintained at the remaining integration or corner points. Regarding labels and states, new level of hierarchy and filtering has been introduced in the states list and animation bar. States are now organized per subcase or step when such levels of hierarchy exist. According to the above, drop-down menus have been added in order to display only states that match subcase and/or label selection. As a result, only the states of the selected subcase and/or active labels will be displayed in the animation bar and states list. Lastly, for states that do not belong to current label, the model is depicted with original state colors instead of fringe. Another new feature is the option to eliminate rigid body motion by subtracting the average motion of a group of nodes. In the depicted example, the target is to eliminate the rigid body motion of the drop model. A group of nodes is given as an input. The center of gravity of these nodes is calculated. The average translation and rotation of these nodes around the center of gravity are also calculated. These average movements are then subtracted from the whole model. Moving on to the solutions for result queries and reporting, the first new feature is the histogram plots. They are available for various entities such as PIDs, isofunctions, and planes. The option is available both in the PID list and in the statistics tool. It is possible to create histograms over the scalar and vector results, as well as over special functions such as IDs, area, coordinates, etc. Various y-axis value types are also available. For example, you can view the results as a percentage of the total elements instead of the absolute number. Finally, in the statistics tool, normal and shear moments can be displayed as additional columns. The user must define a center of rotation manually under moments or select a local coordinate system in the integral options window. Moving on to annotations, the explode of functionality has been greatly improved. Annotations are now placed outside of the model area, but better positioned and closer to the pointer position. Additionally, the context menu Explode on Model has been renamed to Fix Overlapping for clarity. It is also possible to create annotations with more than one pointers to facilitate annotating. Annotations with more than one pointer is available for attachment places at elements, nodes, parts, materials, groups, models, and curves. Additional annotation variables have been added as well. Finally, new script methods and optional arguments have been also introduced. A setting for pointer information and annotations on multiple models is available. If the option is activated, we get information about ID, type, and model ID. Also new is the option to flatten the mesh of a PID and create a planar view of it strictly for visualization purposes. There is a new option to show the property thickness directly when identifying a part. In circular parametric point paths, it is now possible to use the circular angle as abscissa when creating a 2D plot. Finally, when plotting positions and deformation from the From Model Entities functionality, it is now possible to do this with respect to a coordinate system. Moving on to cut planes, it is now possible to easily create plots of a label over a section through cut planes. It is possible to display a section only on specific PIDs. In the context menu of a cutting plane, under the Calculate menu, we added the option to calculate moments of inertia, and the results are printed in the info window. In previous versions, we added the option to animate the plane using a parametric point path. We now added the option that disables following this normal during the animation, which was the default option. Another new option is the creation of coordinate systems for planes, either by picking the plane from the screen or by selecting it from the list of existing planes. A further new option is the option to create a cut plane that best fits a group of selected nodes. In practice, this new feature facilitates the measurement of distances. Finally, there is a new setting available that allows the creation of default planes with their origin being based on the center of gravity of the visible entities rather than the center of gravity of all the entities of the model. Moving on to reporting, reports in HTML format can now be exported from Report Composer. To navigate through the pages, there is a navigation pane and corresponding arrows. Hyperlinks are also available. 3D models in GLTF format can also be loaded and used. Finally, video and audio are also available for the HTML reports. Another new feature is that linear integral convolution results can now be exported to U3D PDF format. In the advanced filter, when collecting nodes or elements with the min-max regions or min-max local extremes options, a new distance criterion is now available. A distance threshold value can be given, the areas closer than this distance are merged, and only the highest or lowest value is kept. Let's move on to the solutions for the 2D plot. It is now possible to create plots with custom layouts. This new feature is available through either the plot options or the respective menu bar at the bottom of the meta window. It is possible to create up to 10 × 10 plots. Options to merge and split plots are also available. The relative size of the plots regarding width and height can be manually adjusted. Finally, new plot layout commands are also introduced to better facilitate the functionality. The new filtering mechanism has also been implemented in all lists of read results curves GUI. The Modify Curve interface has been changed to offer the trim, delete up and down, break and join functionality in a much simpler way. The same functionality has been added as Modify option in the context menu of curves. Finally, it is also possible to select the color palette from which the new curves will be colored. If the curves are going to be plotted in the new window, then this functionality is available through the Settings tab. Or, if the curves are going to be created in an existing window, the functionality is available in the plot options. Regarding the reading of curves, another new feature is to save curves in MetaDB files and then read them back in Meta. In this case, a GUI interface to select results is provided. Furthermore, it is possible to read curves from animator databases and 2D nodal results from H3D databases. Now let's check the new features in crash and safety. A new toolbar, the Deployable Bonnet Systems Assessment, is now available. It evaluates the timing of system deployments with head of impact time and wraparound distance calculations. Furthermore, a wraparound distance versus head of impact time plot for all pedestrian statures is created. And finally, the bonnet deflection due to body loading is also assessed. Another new toolbar is the FMVSS 226 toolbar, which evaluates and reports ejection mitigation results. It evaluates glazing and up to 5 airbags, and the supported decks are LS-DYNA, PAMCRASH, and Radius. Concerning the FMVSS toolbar, there is a GUI redesign. Backward compatibility for existing session files is of course maintained. It is now possible to use configuration files to save and read the input data of the toolbar. Finally, ISO channel format is now supported for 2D and custom post-processing. Moving on to Occupant Injury Criteria toolbar, it is now possible to swap position of two plots. Side impact IIHS version 2 protocol is supported. Thor 50 injury risk probabilities are now calculated and added in the PPTX report for US and CAP. M95 Global Human Body Model and Simplify models are also supported. Versions 1.11 and 3.10 are supported for H350 and H305 anthropomorphic test devices respectively. Even more results are calculated for Thor 50, H305, H3 3-year-old and H3 6-year-old dummies. It is now possible to extract specific restraint results such as steering column, belts and airbags for each processed occupant. It is also possible to use multiple entity IDs for CA channels separated by $signs. In this case, the tool will try to plot the curve for ID 1, and if no curve is created, it will try to plot the curve for ID 2, and so on until a curve is created. Finally, another new feature is the option to export all created curves in ASCII format files, where one file is created for each curve. Moving on to the IIHS toolbar, the Side Impact IIHS version 2 protocol is supported. And for Side Impact, it is possible to set user-defined limit values. Furthermore, a GUI redesign has taken place, maintaining, of course, backwards compatibility. It is now possible to overlay results from many simulation runs in the same intrusion plots. Intrusions calculation at the passenger side for small overlap front impact is also supported. And custom intrusion plots for front impact are now available, using default plot options in any order. Creating new positions is also available. Moving on to the pedestrian toolbar, Euro NCAP 2023 is now supported, and it is now possible to show only one target point when multiple ones coincide. Furthermore, PAMCRASH CRF file format is now supported. In addition, the latest Euro NCAP spreadsheet is now used while exporting the default spreadsheet. It is also possible to export the EU projected areas of each hit range as geometry files. A new scalar label is now added when creating annotations from results overview representing the calculated score of the respective regulation. Last but not least, it is possible to define the impactor type for CNCAP lower leg form, since the Humanetics impactor is now also supported. In the Human Body Models toolbar, it is now possible to select specific slides to be added in the PPTX report. Brain strain damage measure and strain energy density criterion for soft tissue abdominal organs can be added in the PPTX report as well. Lastly, a slide with chest punch compression can also be created. Let's now proceed to the NVH discipline. Hydromounts are now available as connector types in FRF assembly. The analytical transfer function of the depicted realization is now taken into account. Curves for dynamic stiffness and loss angle are available in the Curves tab. Sensitivities of responses with respect to all hydromount parameters can be requested. In the FRF assembly and modal response tools, it is now possible to output calculation results directly to punch file format. In addition, grid sets can be also used for fluid structure interface calculation rather than just element sets that were used in previous versions. In the Modal Response tool, a new tab for handling modal matrices from Nastran and Meta-FSI, such as viscous damping, complex stiffness, FS coupling, and poroelastic materials, is now available. Following features are introduced: reading of additional matrices, switching matrices on and off, and scaling of matrices. Furthermore, Meta-FSI can be combined with PEM what-if studies. And finally, Abaqus complex modes have also been supported. Regarding transient stresses, time domain, elemental and nodal stress strain results can be calculated in modal response. Various options are available, such as top and bottom, von Mises, full tensor, etc. The only requirement is that the modal results loaded must contain stress and strain results. The calculated results can be visualized both in 2D and in 3D. Finally, there is perfect correlation with Nastran results. Another new feature is that an acoustic source can now be used as excitation in modal response and FRF assembly tools. Moving on to fractions, it is now possible to group fractions according to curve attributes. It is possible to view the contributions as values instead of percentages. It is also possible to ignore the phase and to show the residual values as well. A new toolbar, the Participation Analysis Study toolbar, has also been added. For this toolbar, grid, panel, or modal participation results are required. The user is able to run what-if scenarios by changing the corresponding participation factors in order to spot areas contributing the most to the final response. An optimization algorithm is also available, providing hints on how to treat candidate grids, areas, and modes to bring the response to the required level. Another new toolbar, the Opening Distortion Fingerprint toolbar, has been added. It evaluates body stiffness through the distortion in closure openings. It is based on dynamic simulations and measurements. The distortion evaluation is provided in the form of max bar charts as well as over frequency range. Finally, a direct comparison between measurement and computation is also possible. Moving on to the Identify Global and Local Modes toolbar, the geometry and results reading now takes place in the main interface. As such, the Read Results tab of the toolbar is no longer available. Modal results from any deck are now supported, and there is also the option to identify modes based on strain energy. Modal results from OptiStruct H3D and Pankras ERF files are now supported in Modal Response, Modal Model Builder, and Modal FRF correlation tools. In the Modal and FRF correlation tool, calculation of mass and stiffness orthogonality between FE and measured modes has been added. Also, there is a GUI redesign to offer modal correlation, FRF correlation, and orthogonality more clearly. The Modal Model Builder now displays the viscous and structural damping and is now able to output diagonal and non-diagonal damping matrices. The non-diagonal matrices can be output as Nastran demix along with the ASCII model. Regarding solutions for fatigue, through the new features of modal response and random response tool, it is now possible to perform a random vibration analysis given the modal stresses of the structure and the PSD of the excitation. In specific, the new features are that modal response tool is now able to output results into MetaDB format directly. Random response tool supports the MetaDB format as frequency response input, and together with the PSD, the random vibration analysis is performed. Moving on to solutions for CFD. In the user field function, we can now use in our calculations the boundary layer height, the skin friction, the Mach number, and the lambda2 results of our simulations. The calculation of lines along separation and attachment lines is now possible. There is a new algorithm for visualizing results on both sides of zero thickness walls depending on which one is checked at each moment. The generation of streamlines based on flow of SPH particles is now possible. It is now possible to unroll a cylindrical isofunction. Additionally, it is possible to develop isofunctions from a PID adjacent to a region with rotational symmetry. A cylindrical isofunction can also be created from a rotating region. The CFD options tab that allows a definition of CFD reference values as well as additional reading options is now supported. It is available only when loading CFD result files. Moving on to optimization. In the topometry optimization toolbar, mass histograms can now be created. Moreover, mass and mass difference table can now be displayed in statistics in order to easily inspect the amount of the achieved mass reduction for each PID. Let's move on to the solutions for data management. Assam ODS version 5 and version 6 servers are now supported and their data can be accessed and viewed through the DM browser tool. The capabilities offered include viewing the collected items in various simple or hierarchical views, applying queries to fetch instances of application elements, viewing attributes and relationships of the instances of application elements, and finally, curves, images, videos, or other data can be sent to be viewed in MetaViewer. If you select an application instance in DM browser, info about the relationship type is now shown for all its related instances. The info is available in the References Where Used tab. Until previously, all application elements were listed in the content list of DM browser. Now, there is a context menu option to list all, basic, or top application elements. By default, basic application elements are now listed. It is now possible to use session commands to load curves, images, videos, PPTX reports, and key values from a data management repository. Regarding solutions for MetaDB and results output, compression of displacements have been enhanced in the lossy MetaDB compression algorithm. There is an improved compression ratio for share results in general. And finally, there is a new option to further compress large displacements. Moving on to loading of MetaDB results, there is significant performance improvement when reading computationally expensive results from a MetaDB file that contains all the primary results. Concerning the functionality to convert solver databases to MetaDB by maintaining solver capabilities, Radios and EnSite have also been supported. Derived results are calculated upon reading. A new toolbar, the Output Initial Stress Strain toolbar, is now available to facilitate the output of stress and strain results. It allows for the export of initial stress and initial strain keywords in a key file. Moving on to the Solver Support section. Regarding ANSYS, CM keyword and 2022 R1 format changes have been supported. Regarding LS-DYNA, history output allowed SSD files have also been supported. In Radios, H3D file is supported as its original solver. If imported geometry is originated from Radios, the entities' names and their display is now consistent with Radios. The input still needs to be realized through the Hyperview option. Regarding Hyperview, H3D version 2021.2 has been supported. Moving on to FEMZIP, versions 1.7.5 for Nastran, 12.06 for LS-DYNA, PAMCRAS and Radios, and 11.91 for ERF has been supported. Finally, regarding animator databases, FEMZIP version 12.06 has also been supported. Moving on to the collaboration section. Following features have been introduced in the web interface. Visible entities are now available. Identify actions have been supported both for 3D models and for curves. Moving on to process automation, it is now possible to collect results directly as NumPy arrays for direct using calculations. And there is also improved performance on methods that collect and create results. Furthermore, functions have been added to check if an object linked to a meta-entity is still valid. Methods to save images and videos are added and are available for Windows and Pages. And finally, in cases when a script terminates with an exception, the GL area is redrawn automatically. Moving on to the Toolbar Development Kit, new functions are implemented to display messages, ask questions, and return objects of an item. Additional improvements have been implemented to check for duplicate names in toolbar items, to return the same generated object as the utils meta command, and to match the visual style of meta when issuing warnings, errors, and information. Moving on to the solutions for virtual and augmented reality. After supporting the HoloLens 2 headset, it is now possible to participate in collaboration sessions in augmented reality, together with desktop and VR users. Adding to this, we have also implemented scene understanding, enabled the real-time perception and interpretation of a scene with physical objects in augmented reality. In the area of NVH, in virtual reality, acoustic analysis has been supported, allowing users to listen to the sound pressure levels and mark the acoustic source. Regarding VR collaboration, the drawing performance of custom avatars is greatly improved. Desktop collaborators are no longer forced to follow the operator's view and are able to set their view freely during a collaboration session. In order to join and follow the view of a VR user, the option to watch a collaborator's view is added. Vosk offline speech recognition is now used for the voice-to-text dictation functionality, with additional capabilities of spelling and number dictation modes. Finally, enhanced user experience is achieved with a new animation mode that allows the user to follow the model animation while being inside VR. Thank you very much for watching.